Hello everyone, I am Vardhini Valluru from the Project 1. We have been working on this project from the past 2 months with the title Customer Segmentation and Market Basket Analysis. My part of this project was customer segmentation. I have used k-means clustering from all the partitioning methods of clustering techniques because it was more appropriate for our data set because it divides the customers in the segments of more appropriate manner. With the centroid, we can centroid being ideal for all the customers being in that segment. As I said, clustering, K-means clustering is an important technique and it is a very appropriate technique to divide the segments of customers. So the performance of K-means clustering is high and effective. To divide customers, we use K-means clustering, and in the same way, to find the optimal number of clusters, we use elbow method. Elbow method is basically a graph or plot between the computational effort and the number of clusters. We know that with increasing the number of clusters, the efficiency increases. But there will be a point in which the clusters, the number of the making of clusters takes more up computational effort. At that point, the amount of computation effort given and the accuracy is not matchable. So that point is the break point and it is also known as the elbow point. Let me share the code of the elbow method. As we can see here, the features 257 from the dataset which we can consider as as we can see from the dataset here, this feature 2 is age, 5 is spending score, and 7 is quantity. Here we can see that these three features are considered as variable x. We will be using these three features for our clustering technique. In the code here, we can see we have used the elbow method to find the number of clusters using least square method. As we can see the graph, it is WCSS versus the number of clusters, and out of all in this whole graph, at 3, we have a breakpoint. This is the elbow point for our clustering. I have used this code to divide each customer into his respective segment. So the first customer of our dataset belongs to the cluster 2, the second belongs to the cluster 1, the third belongs to the cluster 2, and so on. The first cluster is denoted by the number 0, second cluster is denoted by the 1, and third cluster is denoted by the number 2. That is the reason for a 0 on this. And as we go down, we have the plot for the clusters. The pink cluster is the cluster 1, cluster 2 is the purple, and cluster 3 is the orange one. The yellow are denoted with the centroids. These centroids denote the ideal behavior of the whole cluster. As we can see here, the customers from a specific age group and with an annual income of 10 to 40 belong to this cluster with spending score of 20 to 50 around. So all those customers with this annual income and this spending score are in this particular cluster. Similarly, with the customers from annual income of 40 to 70 in of spending score between 25 to 75 are in the cluster 2. But same with this third cluster. This is basically this is how we basically divided the customers into segments. Now, to test the accuracy of the customers we have used, or the clustering technique we have used the silhouette score, which is used to find the accuracy of the clustering technique. Silhouette score actually ranges from -1 to 1, and since our technique is not that appropriate because of some irrelevant features we have used. However, some are more appropriate. In the silhouette score, which we got was 0.4, as you can see here. 0.6 is very good clustering technique, and when we used all the features with when we tried various features like annual income, spending score, everything, this gave the best accuracy. This is my part of the project I have done.